This is Carl from the Swift Arduino team, and I'm showing you a simple little SwiftUI project here that we use to show the current temperature and humidity values that are coming out of an Arduino board, an Arduino compatible using the Grove technology, which we've got in the sister video, which shows you all the details of how that's hooked up and how this is programmed using Swift for Arduino. This is the client-side code, which just shows a simple screen, temperature and humidity. And I'll just show you how that's put together. So it's two simple classes. One is the view side and one is the model side. So we'll show the view side first. So this is classic SwiftUI. If we pop the canvas on so you can see the preview, you'll see this is really straightforward little layout there. You've basically got the temperature as a text, humidity again text, spaces around the vertical stack, putting in the appropriate colors, and then the horizontal stack we're putting in a background color behind it, a kind of a purplish tint. And there's some sample data that you can see down here in the bottom. So there we're creating one of the models that we're using. So you can see at the top of here, we've got the model as an object binding. So that's coming in from the environment model class, which we're going to show you in a minute, and using object binding. And down here in the preview, we set some demo values, which you can see on the right-hand side. Okay, that's the UI. As standard with SwiftUI, it's really straightforward, simple and declarative. So we'll get into the model and how that works. And this, again, is not really too complicated. So first of all, let's sort of show the external stuff that you've got here that feeds out into the UI. So we've got a temperature property, a humidity property. These are both ints, and these can be null, so they can have no value, or none in another terminology, which is effectively when you unplug the board or something like that, so it'll reset to nil because it doesn't have a value in there. And we've got a couple of string declarations which just break those out. If they're not null, then it puts something in, otherwise it puts in blanks, as you saw just then. And these are the properties that it actually binds to in the UI. And as is standard with the bindable object protocol, we have a will change pass through subjects, which is from combine, and we trigger value changes on that by doing will change send and sending through a void. Okay, so how's this implemented under the hood? Well, it's all using the ORS serial port code, which you can get in a CocoaPod. And we've got one of the serial port objects here. So when that's set, we set ourselves as the delegate, set the baud rate 9600 and open, and this is agreed with the Arduino sketch. When it's set to 0, then we close the port and exit. And we've got a little bit of processing here. You can see the project on GitHub. This isn't terribly interesting, but you're basically looking through all of the ports for ones that begin with USB modem. And down here, you've got the serial port manager, which will be set in the initializer, and you look through the current available ports to see if your port is one of those, and then just take the first. I mean, if there's more than 2 Arduinos plugged in, then it might not get it right, but this is not bad for a prototype. This is parsing a string of data, the data string that comes from the sketch, and just breaks it apart, looks for relevant separators, etc. And down here, you're concatenating serial port data as it comes through in lumps, and then looking for new lines and breaking those apart. It's all really just text processing. This is the monitoring property. So when you set this to true, this starts up the serial port monitoring, and it listens for new serial ports to be plugged in so that you can initialize everything if the Arduino wasn't plugged in to begin with. And down at the bottom here, you're implementing the delegate, the ORS serial port delegate. So really the key thing is when you start this up and you turn the monitoring on, then it'll scan through the existing ports or listen for notifications for new ones plugged in. Set this, that'll open the port, you'll get the serial port data in, it'll collate it using this text processing, read it out, and then the important point is it'll set it on these properties. So it'll read the string, read out the integer properties for temperature and centigrade and humidity, and set them on those. And then through the bindable object protocol and SwiftUI, that'll just get driven directly into the UI, which is really pretty straightforward. The final piece is in the app delegate. We create an environment model, we turn on the monitoring, we save it to a local property so it doesn't, if you close the screen, it doesn't get deallocated, and then we pass it in as the constructor value into the content view that you saw just then. And that's it. So there's a nice bit of code you can pull down from GitHub and use and modify yourself. You get the Swift code in the Swift for Arduino community website. In the working folder in the companion video, you'll see all about how that works. And that's it for tonight.